How and why do animals make colours? Here in Australia, we have this amazing eastern rosella. We also have this awesome rainbow stag beetle. Both of these animals have incredible rainbow coloration, but how do they make this vast array of colours? Let's find out on this episode of Creature Features. This is Dr. Claire Keely, and she's going to answer some of our questions about colours. So Claire, how do animals like birds make colours?
There are a few different ways, but one of the ways that animals make colours is with pigments called melanins. There are the black eumelanins as well as the reddish-brown pheomelanins. So you might be familiar with melanins because they create the colour that we've got in our hair and our skin.
I have pigments in my body, but as much as I would like to be, I am not rainbow coloured. So what are some of the other ways that animals are making colour?
Some birds are getting the colours from their foods. So for instance, carotenoids create reds, oranges and yellow colours. So depending on the food that they're eating, they can produce these colours.
So if you're eating like a good, healthy diet, does it mean you make lots of like bright, attractive, healthy colours?
Yes. For many bird species, the colour of the male can indicate that he is a healthy partner.
So it's always the males that are colourful then?
Not always. Let's look at the eastern rosella. Both the male and the female are brightly coloured, but not because of carotenoids. Australia's parrots, cockatoos and lorikeets have their own special pigments. They're called Psittacofulvins, and they can make them in their feathers.
Okay, so these guys in front of me actually don't have to get their pigments from what they eat.
No, so these pigments are making the reds, oranges and yellows that you see that make parrots and cockatoos super bright. And we've got lots of these types of birds in Australia.
Okay, so why use like a totally different pigment system?
We actually still don't know exactly why they're using different pigments. But since they don't need to eat them, parrots and cockatoos do get to be really brightly coloured. Larger species tend to be more colourful, particularly with reds and blues. We think this might be because of their size, they don't need to rely on camouflage from predators.
So they don't need to be like green to hide in with the leaves and stuff.
Exactly.
So what about blue? That's a piece of the puzzle we haven't really covered yet.
When we look at blue feathers under a microscope, we see these amazing nanostructures. These structures are small enough to interact with individual light waves, and blue light is just the right wavelength to be scattered and reflected off this structure in all directions, making it look blue, but it's not actually pigment. It's called structural coloration. The rest of the colours are absorbed by melanin, or the scattering effect that creates blue can interact with pigment like yellow to create green.
Claire, we've talked a lot about birds, but I know your passion is more like entomology and beetles and stuff, right?
Yes.
Right, so you've brought in some amazing looking beetles here, and I noticed that they're all iridescent, so that the colour that they look changes depending on what angle I'm looking at them from. What's that all about?
So like blue, iridescence is caused by nanostructures, and these structures are made out of a substance called chitin. And chitin's what insects use to create their exoskeletons. Although melanin is still involved in some species to help enhance the contrast of their colours, the nanostructures act like obstacles in the path of light waves, forcing them to change direction. If the spacing between these layers is carefully calibrated, specific colours can be reflected. And these colours also depend on angle. From there, you can get a whole rainbow of colours. Between species, there's a lot of variation in these structures at the nanoscale, but it all comes down to interference with light.
So why do it though? Why be so like colour changing and shiny?
There are a few hypotheses for why beetles are so iridescent. It might just be the result of having a strong exoskeleton made of many layers of chitin. It could be to warn or dazzle predators, or even for camouflage.
That is absolutely fascinating. Thank you so much, Claire, and thank you for bringing in these wonderful beetles.
No problem.
Animals use their colours to attract a mate, blend in with their surroundings, or even ward off predators. We're just lucky enough to be here on the same Earth, watching as they pass us by. If you enjoyed this episode, check out the rest of the playlist and follow the link to our web hub, where you can discover all the ways you're connected to everything on our wondrous planet.